Okay, so hopefully this is working. I am live streaming from my iPad here. I apologize if anyone's in the feed, probably not this soon, but if you're in the feed, I apologize if it's a little bit noisy, if it's a little bit... I'm experiencing a lot of technical issues trying to get this thing working. I've forgotten how I did it in the previous occasions. So I do have some emailed questions. Let me see if I'm actually streaming. So let me just use my other computer here. Hit refresh. Do I get... Ooh. Okay, the name's wrong, but looks like I am streaming, which is a good thing. And I can increase the size. I'll do a pop-out chat. Awesome. So make this nice and big. Sorry, for you, it doesn't look like I'm doing anything, but on my computer, my PC, I've got Windows going on. Anyway, I got one from Sophia. She was asking, I was looking through the revision sheet and I was stuck on a few questions. I was hoping that you could show me how to solve the following questions during the live stream as possible. So she is asking about, I think it was the revision sheet. She's asking about, it looks like question 4 of the simple ones. And it looks like she also took a screen picture of, oh, okay, the number sequences. So maybe she wants, maybe it's this one here. So I'll try and do this one, and she also asked about the one with the cube. Yeah, sorry about the time slot saying 4 p.m. I don't know how to control that. This is a leftover, like some of the settings are left over from probably 2 live streams ago, at least, when I was able to dial things in with a bit more time. Unfortunately, I'm a bit rushed this afternoon. I had some technical issues trying to, anyway, long story. So some of the settings are kind of out of whack. I apologize. But hopefully you can hear me clearly. I plugged in a little microphone here, so hopefully that works. Right, and the sound in the background's probably not too bad. My laptop is thinking pretty hard. So let's get on to these questions here. So complete the following number patterns. Here I got 6, 8, 12, 10. Okay, so one clue that you might have is to memorize the different types of number patterns you might get. So sometimes you have ones that are adding by an even amount every single time. Sometimes they're decreasing by a certain amount every single time. If you notice the numbers seem to get really, really, really big, really, really fast, then that gives you an indication that there might be a multiplication going on. If you see the reverse, where it starts off at a really high number and it drops off quite rapidly, it starts up and starts decreasing quite rapidly, then you might be looking at something that's being divided every few times. However, in this one here, we can see it's going from a low number, a slightly higher number, slightly higher number, and then then it came down again. That gives you a clue that what we're dealing with here is probably 2 alternating patterns, and that's what I've actually done here, where there's a pattern that goes between these numbers, and there is a different pattern, which I'll use blue, going every other number. So 6 to 12, that looks like double, or it could be adding 6. Let's have a look. Next one here, 24. Okay, so that one's getting dramatically bigger every time. So it looks like we are multiplying, and this one here is actually multiplying by 2. So the next one here should be, double that. So that should be 48. And then for the other numbers, 8, 10, 12, it looks like they're just adding up by 2. So another 2 would give me 14. So that gives you that solution there. Question 4, continuing on Sophia's question. Can't watch it. What do you mean, Max? Can't see what you're talking about, dude. I hope it's all right. So it says, enter the following spatial pattern. Each line represents a toothpick. Draw the next 2 terms of the sequence. Well, sort of following along the sequence from here, it looks like I'm adding basically one of these little houses every time, but I'm borrowing some edges from this house, and I add one more. Obviously, I'm sharing some extra edges here, so that edge there is being shared, and that edge there is also being shared. So to do the next 2, I would just copy that. So, oops. No, that's right. I'll probably have the next one looks like that. And the next one after that, I'll probably have 3 up top. There we go. So that's that one there. Write the number sequence up to the 9th term. So the number sequence is how many toothpicks. So let's have a look at what we've got. So in this one here, I've got 1, 2, 3, 4, 5, 6. So I've got 6 edges or 6 toothpicks. Let's count these ones here. It'll be the same as before, right? So I only have to add any extra toothpicks that I can see. So I already have 6. 6, 7, 8, 9, 10, 11. So I've got 11 toothpicks in that one. I already have these edges. So I just have to add up any other edges remaining that I've added. So we got 11, 12, 13, 14, 15. Okay, and I think we're starting to see a pattern here, where from here to here, I have added, I think, 5 toothpicks. From here to here, now that I've established my pattern, I'm actually adding plus 4 toothpicks. And you'll find that if you actually count the rest out, we are adding 4, adding 4, adding 4, and so on. So if this is the first one, this is the second term, this is the third term, this is the fourth term, this is the fifth term, and so on, then we can actually write out the number sequence. So the first term had 6 edges. The second term had 11 edges, or sorry, toothpicks. The third term had 15. Now that's the ones I counted. From here, I can just calculate them. So I'm just going to keep on adding 4. But I'm also going to make sure I get all the way up to 9 terms. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, probably didn't leave myself enough room there. So to get to the fourth term, I just add 4. That gives me 19. Add another 4, I should get 23. Add another 4, I should get 27. Add another 4 again, I should get 31. Add another 4, I should get 35. Add another 4, I should get 39 toothpicks. I think that's what my solution was. If not, I've probably just added the number 4 incorrectly while trying to go in very quick. Last one from Sophia. She asked about the one that was the cube. This one here, how to calculate this one. So here it's asking us about surface area. That means all the area on the surface of this object. And basically, you can just add a lot of these things together. So on my solutions here, I just sort of pointed out how many faces. A face is like, I'm looking at a cube. You know, this would be called one of the faces of that object. Okay. So I was just basically looking for how many identical faces does this cube have. Well, so far I've identified there's going to be 4 of them, plus the one on the bottom. So my area, my surface area, so SA, you could just put A if you wanted to. My surface area is going to be 4 times that shape, which is the one face, which has an edge length of 5, right? Plus, we've got to figure out the top. So I'm going to have to add up the surface area of the top, and the top has a little hole cut out in it. Now, it turns out that if you're just looking from straight above, we are trying to look at all this area, but also the area on the bottom of the hole, which is still going to add up in total to be exactly like one of these. So I can actually modify my rule here if I wanted to, but I won't. I could just make this 5 times the square. And then after that, I have to add all the bits in the middle. So let me just highlight that in something that we can see on screen. So I need to and use yellow. Yellow might be a better highlighting tool. So I need to basically add up these faces on the inside. So that's what I'm going to do. So I have to add up, and there's going to be 4 of them. 1, 2, 3, 4 of those. So 4 copies of this little inside shape. So that's how I did my solution. So 4 times the large face of the cube, which is 5 times 5, plus another one of those. So it's going to be 5 times 5, plus 4 lots of the interior. So I have to zoom in here to see what dimensions I've used. So it looks like I had one length is 2 centimeters, the other length I've covered up, can't see it, use my Mac, 1 centimeter, So it looks like a 2 by 1. So 2 centimeters by 1 centimeter. Now I just calculate everything through. So 4 times 25 plus 25 plus 4 times 2. So I basically have 5 times 25. So 25, 50, 75, 100, 125. 125 plus 8. So it should be, I think that. Not too confident. I did do this sort of number crunching too really, really quickly. Sometimes, well, often in class when I do it really quickly, I make little mistakes along the way. I'm sure you all have identified my mistake. So it looks like Brooks identified 5 times 6. What? Yeah, Brooke, I include the bottom here. Oh yeah, you're right. You're right. I should fix that number there, because I counted, if I only use 4, that only counts these faces out there, but I didn't count my bottom, so that should be a 5. So that should be 5. This would also add to it as well, if I really wanted to. But anyway, I think you get the point. I think the main struggle was how do you figure out the top bit. So apologies that this video is not the best it could be. I'm really rattled from all the technical issues I've just experienced over the last hour trying to get my computer working. So sorry, I'll try and slow down and do things more carefully. Thanks, Brooke, for bringing that up. We're all smarter now because you identified I forgot a number. I think Sophia had one last thing. If you have time, can you show how to solve that last question of the revision sheet? So let me see what that one was. Oh, this is the chemistry cat one. Well, I think other people might want to have questions about this one as well, so I might come back to this in a little bit. I just want to see if I can answer any quick questions. So if anyone has a quick question in the chat feed, I'll try and answer those first. So let me just have a look to the feed. So we've got Kate's here, Brooks here, David's here, Max can't see, restricted mode, school account. How do you use the unit circle? So unit circle sounds like you might be doing some trigonometry. That's a little bit beyond what I'm working on here today, just because there's a lot of students, I'm sure, that have a lot of questions for me. Okay, I don't see any questions in the chat feed. So I do have an email from David though. So I'll go to David. The live stream, could you briefly run over some algebra questions, solving equations like that? Thank you. Regards, David. So David, I won't run through them here on the live stream because you didn't give me anything specific. I have done my best to try and generate some problems, and so something I recommend you do is go to Firefly, and on Firefly I've actually uploaded this file here, and I call them trap questions. So I don't know if I can do this on the screen. Let me see. If I go to Firefly. Just basically pointing out where you can find more resources. So I'm going to the 7 Maths page and going to the Term 3 page of that. You can see the stuff that I've put there for you. So up the top here, we've got these, the Term 3 revision sheet, which has some, I think it has a little bit of algebra in there. If not, I'll probably have it somewhere else. We've got shapes, we've got surface area, we've got paint cans. Yeah, we do have equations, dude. So it is on the Firefly page on the Term 3 revision sheet. But you might also want to try some of my trap questions here. So I've uploaded this. I finished uploading them on Friday afternoon. And so I have the questions themselves and the solutions, so you can give those a try. So I hope that answers your question, Dave. Now just checking with the chat feed. Is there anyone here who's got a quick question for me? Let's see. How do you algebraically solve simultaneous equations? So it looks like Jeff is from an older, like from a not in year 7. So Simultaneous equations, it's been a really long time since I've done those. I haven't been teaching high school maths uh, for ages. But I think the principle is that if you have I think if you have two equations, let's say I've got 2x plus 5, and I have another one, let's say 3x plus 2 equals, I don't know, 3y. I think for simultaneous equations, you add them together. So I think this is the way it works. Okay, so maybe this will trigger your memory, Jeff, if you've been going through your lessons. I think you add them together. So these are both the left-hand side of the equation. So if I add those, I should have y plus 3x plus 2. I think that's part of your story. I can't remember exactly how it's done. Sorry, dude. I can't give you any better help than that. But I think it does involve adding the equations together, stacking them, like you're sort of kind of like Tetris blocks. When everything lines up, it just sort of slams down and you squish them all together. Hey, Jacob, welcome to the live stream. Let me keep reading through. Is a pronumeral, so Rolling Stones, which I think is Brooke. Rolling Stones asks, is pronumeral, or pronumeral, just like letters to substitute the letters? Substitute the number. Oh, okay. Is pronumeral just like letters to substitute the numbers? Yeah. Pronumerals. Okay. So that should just translate that into English. I describe them in my lessons that for a pronumeral, they are just temporary numbers. Placeholder letters. Okay, so that should give you two little scenarios here. So pronumerals are just the letters that you see in algebra, and we use them as temporary placeholders. Okay, and that is a really good thing because we can use that structure, and that's the whole underpinning of algebra. We can use this structure to build instructions for computers to calculate hundreds and hundreds of thousands of things for us. All we have to do is just give them the commands in algebra format, where you might have a placeholder, say, okay, calculator, whatever I give to you, can you just add it to the previous thing that I gave to you? So if I keep feeding you another number, like let's say I'm doing my taxes, for example, I could just get my computer to algebraically just, okay, computer, just add the new number to the previous number. And just keep doing that over and over again. And, what number? Oh, just, look, let's call that X for now. And you can use that as a temporary letter placeholder. Okay, moving on. Any other quick questions? Kate's, okay, so Rolling Stones is on 2 accounts. Interesting. Where's the revision sheet answers? Revision sheet answers will go up live on Monday. I just want to make sure you guys had a chance to try the entire sheet before I spoil it all for you. But if it becomes a real problem, I might stick it up on Sunday. But I'm hoping you guys are finding some benefit out of trying to do as many questions as you can. I designed the real revision sheet here, so this document, which I can flip over to here. So this document that I think you guys recognize, I made this so that you could sit at home, try as much as you can, and then I would give the answers to your mum and dad. So if you're in my math classes, I've emailed the answers to mum and dad, so that you can basically talk to them and see, okay, well, these are the questions, these are the ones I could do. Let's have a look together with what the answers are, and you both can see where things are going wrong or where things are going right. And because I find that when I'm talking to parents, at the end of term, for some parents, it's they don't really get to see how good you are, how good you're going. sometimes they can't really see until like the very end of term when the report card comes out, and that can be a bit of a surprise. So the idea with this little formats is that I give the answers to the parents, I give the questions to you, and that way you can sort of do that communication. And sometimes, you know, my time is limited. Obviously, I'm here on the live stream, but like there's hundreds of kids, right? And I can't spend individual time with every single one of them trying to figure out where you're going wrong. But your parents can. So if I give your parents the full answers, then they can have a look at how you've responded and how I've responded on them and see where those differences are. Sort of, you know, you could work together as a team to see where you're getting caught up. So that was the intent. Obviously, every teacher is different in the maths teaching team. So some teachers have given you this sheet as like a little test to do. So it was intended to be like a revision sheet, but not necessarily a test. But if you did it as a test, then that still has the same sort of outcome where you give a try, see what you can do, what you can't do, and basically learn from it. But I can stick, if it's a real problem, can you let me know in the chat feed if it's a real problem? I can stick the answers up maybe Sunday. Let's keep reading through the chat feed questions. Dave asks, could you please go over solving equations again? Oh, okay. So I saw your email, Dave, and I think I understand what you are asking for now. So I just responded to you earlier, David, that there are revision materials specifically to practice solving equations, but perhaps what you're really asking for is basically how is it done? Okay, so if I make an equation, give me a second, it's probably going to be pretty ugly because I haven't had time to think and make it a really nice one. I don't know, 50? Okay, so here's an equation. How can I tell it's an equation? Well, there's an equal sign in the middle of it. And the basic process with an equation is that some teachers would describe this as like a balance beam, right? So if you can imagine the equal sign is where your fulcrum is. Remember that we did this in physics not too long ago for science. And things are only equal if both sides balance out, right? If these two sides don't actually equal each other, then my balance beam would tip over, wouldn't it? So that's one main concept that's going to lead me to the next bit in terms of solving it, is that you solve equations by doing operations to it identically on both sides, okay? So let me just bring up this analogy with a seesaw. So let's say I've got, you know, Uncle Snapper, he's sitting over here, and he's got a little hat on. And let's say I've got like Mathilda. She's lost. I don't know what happened just now. Okay, so I might be able to move Mathilda to just the right position to sort of balance this out. So I might bring Uncle Snapper in. So let's forget his legs for now. Okay, so all right. So let's say I have now made these two quantities of mass equivalent, so my balance beam actually stays level. But if I was to change anything to this equation, I must do the same amount or do the exact same thing to both sides. So if I was to add more people to it, so if I add a person, I must add the same equivalent mass to both sides in the exact same place. If I don't, then I ruin my balance and therefore I would lose the equal sign. So I could add as many people as I like. I could double how many Uncle Snappers there are I could double everything, I could subtract everything, as long as it's the same amount from both sides. That's the main concept, okay? So with that, what I'm going to do is when you try and solve an equation, you are trying to isolate the letter. Try and make the letter all by itself on one side of the equal sign. It doesn't matter if it's over here, or if sometimes you make it over here. It's just traditionally over this side, so it looks right, it looks good to have the pronumeral on the left-hand side, but you know, I don't really care. So I can see that I need to get rid of this item, right? If I can just move that away, I'm getting one step closer to getting the letter X all by itself. But I can't do that unless I use a operation, right? So with mathematical operations, you have to look at what sign is there and do the opposite. So here I've got 4x plus 15. So what's the opposite of plusing 15? Is to subtract 15. So I'm actually going to do subtract 15 from both sides. So that means that goes away. So what's left behind would be 4x equals, okay, 50 take 15 would be like 35, I think. Can Brooke double check my maths there? Okay, and then now I'm nearly there, so the letter X is nearly all by itself. I have to zoom in here for a minute and look between the lines here, and if I look really hard, between the 4 and the letter is a time symbol. So what's the opposite of 4 times the X? That's to divide your answer by 4. So if I take that response and I divide by 4 on both sides, then 4 times, and then divide it by 4 again, that cancels out to nothing, doesn't it? So all that remains is just x. And on the right-hand side, I have 35 divided by 4. Now, because I didn't make it really nice, this doesn't really simplify to anything nicer, but that's just life. Often algebra doesn't always work out beautifully nice and neat. So I hope that helps you answer your question, Dave. Let's see. B asks, can you go over the question where Mathilda is in the middle of the square? Oh yeah, sure. That's pretty simple to do. So here's Mathilda. She's inside of a square, and we are to calculate area. So area. Oh, my pen is very thick. So area is going to be the area of the big square, which I'll color in pink for you. And I'm going to subtract the little square or the window that she's looking through. So if I just use that to sort of guide me on how to solve this one, I can just take those 2 dimensions for the giant pink square, which is length times width, which is going to be 10 centimeters times by 12 centimeters. Subtract the window that Mathilda, the turtle, is looking through. So notice how I'm grouping these things with, notice how I'm using brackets to try and group things together. It's a really good way of just keeping your communication, your working out. It's a really good way to keep things neat and tidy. Because sometimes if you just make a really long line of working, I find that I get a little bit lost unless I sort of group things together nice and neatly. So this is the window, 4 times 5 centimeters, because it is also length times width to do the area of a little rectangle. So that ends up being 120 centimeters squared. Subtract 4 times 5 is 20, so 20 centimeters squared. And that gives us a total answer of 100 centimeters squared. Now the reason why it is centimeters squared is because centimeters times centimeters is going to be centimeters squared. That's why. I hope that answers your question B. Moving on, Rolling Stones asks, can you please explain the wording of question 6? Question 6 of what? Can Rolling Stones clarify which section of which paper? Because I'm a little bit lost, to be honest. Hey, Fred's jumped in. How do you find the prime decomposition of numbers? Is it just finding the prime factors of one numbers? And then can there be more than one answer for prime decomposition? So that one's probably coming from the prime decomposition. It's probably from these ones, hey? So prime decomposition, if we turn back to our class notes, Fred, so I'll go to the 7K lesson, we had prime decomposition. Let me go find it. We must have started chapter 3. Here we go. So to decompose something means to break it down to pieces, and if we're doing prime decomposition, we're basically breaking things down into its fundamental primes. Okay? So if I was to take the number 12 and do the prime decomposition, that means I need to express it as a series of prime numbers multiplied all together in a chain. Okay, and if you see if you see two of them that have the same number, you can just group them together using index notation, or also known as exponent notation, or indices, or they're all the same thing. How do you find one though? Well, you use the factor tree, so the decomposition. Yeah, it's a factor tree. Use that. So, for example, what's happening inside this tree here is that I take the original number of 40 and I go, okay, well, that's an even number, so I could divide 40 by 2, and it's basically 2 times 20 gives me the original. But I realize that 20 is a composite number, so it can be further made up of smaller factors. So I know that 2 times 10 would give me 20, and you keep going down the chain. And it turns out, for prime decomposition, it doesn't matter what you start with at the very beginning of your tree. You will always end with the same primes on the ends of your branches. So it doesn't matter which ones you start with, okay? So you could have perhaps started with 40, like let's just do a proof of concept here. So I'll do a new one. Let me do this one in pink. So here's my new factor tree of 40. Let's, instead of dividing it by 2 on the outset, let's divide it by 5. 5 times 8. Okay, 8 is a composite number, so I can break that up into 2 times 4, and 4 can be 2 times 2. Now if I look at my tree, I've got a 5, a 2, a 2, and a 2, which matches exactly what we have here. So it doesn't matter how you break down or how you start your factor tree when doing a prime decomposition. I hope that helps, Fred. Let me just rub this out. Going back to the next questions on the feed. Rolling Stone says, how is this revision sheet in comparison to the real one? Harder or easier? The term 3 revision sheet, so this one here took me an hour to solve it with all the working and all the things like that. The final exam took me 28 minutes, so quite a bit quicker. I'm still going to give you 70 minutes of time to solve it, plus your perusal time. So you should have a lot more breathing space to think your answers through. In terms of difficulty, my preference is to make the revision material a little bit harder. That way, when I ask you something simple, you can do it. So, for example, I'm sure people who do sport, they train themselves just a little, like they train themselves quite a bit harder than they would need to perform in a real game, and that way that they have a little bit left in the tank to handle any situation that they have to, whatever demands of them. So that was my thinking, is that I just wanted to give you a single revision sheet which gives you quite a good coverage of the entire term. So yes, it's quite long, so it took me an hour to solve everything, but I did it because I didn't want to leave you missing any sort of, like, leaving anything uncovered. So I thought it was better if I just have everything from chapter 3, chapter 10, chapter 11, and the Best Buys bit that we did, a little bit of everything, and I tried to make it so that it wasn't immediately simple, because think about it, you've already practiced the basic ones in the book. At least that's my opinion. Like a lot of the questions we practice during class from the textbook are usually the very simple and very straightforward questions. However, those are very typical of a simple familiar. And I'm sort of guessing by now that you've done quite a bit of simple familiar. So, to step yourself up to the next level is to sort of try something a little bit harder. Try something that's not immediately obvious. Try something that's not going to necessarily simplify nicely, because life is not always going to be nice and neat, especially when you're dealing with numbers. You're going to have answers that work out with an infinite number of decimal places, and they never seem to have a repeating pattern. It just goes on forever. That's just the way life works. So that was my thinking. If you stressed out over this term 3 revision sheet, I do apologize. I see that some classes use it as an in-class test, which I thought was a bit, that's quite a lot to ask in a single sitting. But I still hope that you get benefit out of it when you see the solutions, and you can look at your answers and look at my answers and sort of learn from the two. Mystic asks, this is Alex from 7D. Oh, hey, Alex. Can you please go through area, volume, perimeter again? Okay. Let me go to our class notes then. So let's go to, I think area must have been chapter 3, I think. Chapter 3. Let's go. So perimeter. Perimeter means the outside length. So if I have any object, so if I've got a triangle and I want to find the perimeter, I basically have to figure out what numbers over here, what numbers over here, what numbers over here, and add all those together. That would give you the perimeter. Okay? If I have the only thing I can do to trick you, and this is some real like inside baseball sort of things, the only thing I can do to trick you with perimeter is to make you work a little bit harder to try and find out one of those other lengths. Or maybe more of those other lengths. So for example, let's look at a triangle example here. Let's say I give you 10 on that side, and let's say this one here is 9, and this other length here, I don't tell you what it is, but I use this notation. So now it's a little bit harder. Oh dear, it's 2:30 already. I don't know if my battery on my Mac is gonna, ooh, I'm on 28% on my Mac. Well, I'll keep live streaming until my computer literally powers off. I hope I'm getting through some solutions here for you all. Yeah, so here you would have to use the stick notation to figure out that this means that these are matching lengths, therefore this length here must be 9, therefore my perimeter must be 9 plus 9 plus 10. Okay? Another trick that I might do to try and make you think a little bit harder is that let's say I give you a shape like this, okay? Pretend it's nice and square. And let's say I give you, this is 10, and this is 14, but I don't give you any other measurements, not even stick notation. Well, you have to think a little bit harder. So let me look at this length here. Well, that's 14 somethings long. Well, surely this piece plus this piece would also be 14 somethings long. And that's all I really need, don't I? And likewise with the other dimension, where this side here is worth 10, surely this area plus this area would also be 10. So my total perimeter is basically going to be 2 groups of the 14 plus 2 groups of the 10. Okay? For area, that's a little bit too much to go into right now because I realize my battery's dying and I haven't answered that many questions right now. But the basic principles of area is that you're trying to figure out how many squares fit inside of your shape. Okay, so I'll just keep on doing this and see how many fit inside. Now, what square do we use? We tend to use a unit square. So, for example, I could use a 1 centimeter by 1 centimeter square, and I can just see how many of those fit in there. Well, if it's a certain size, I can just do copy, paste, 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 and let's say it fits in there beautifully. Okay, I don't think it does, but let me just pretend it does. Okay, here I might give you a dimension on your shape here. I might say this is 1, 2, 3, 4, 5. Let's say I tell you it's 6 centimeters. Well, it already gives you a clue. And let's say I give you this dimension here, which is 5 centimeters. Well, I can see it fits 5 centimeters across. 5 cubes will fit across. Sorry, 5 squares. And I'm speaking too quickly. 6 squares fit across the horizontal. 5 squares fit along the vertical. Then if I want to find out how many in the entire space, it's going to be 6 times 5. Okay, 6 centimeters times 5 centimeters. If I'm doing volume, let's go volume. Volume is a measure of how much space an object occupies. Okay, and we do this again. Instead of using unit squares, we're using cubes to see how many cubes fit inside. So if I give you a basic prism shape, okay, so here's a rectangular prism, how many cubes can fit in there? Well, you can get a clue by looking at the surface, okay? So let's say for this surface it fits, let's say it's 3 wide and 1, 2, 3, 4, 5, and 5 wide. So this area itself would be 3 times 5, which gives us 15. So it'd be 15 squares inside there. But how many layers of cubes would that be? Well, and each being a centimeter cube, well, let's say this bit here is, 10, it's 10 units this way, then that means I'm going to get 10 layers of cubes. So I basically have 3 times 5 to give me this space, times the depth, which tells me how many layers all the way down. Okay? Now that works for any cuboid, roughly blocky looking shape. Let me just backspace because I don't want to undo all my beautiful drawings here. So here you would get a rule for a rectangular prism, length times width times the depth, or how tall it is. You could use a H, I don't really care. So if I give you any shape, so let me go to the live stream. So if I give you, I don't know, I think I gave you guys this problem where we have a parallelogram, right? Well, the parallelogram prism would just be the area of the top face, how many squares fit in there, and you would do that using the regular rule for a parallelogram's area, and then you would try and figure out how many layers of cubes could I fit in there, and so you would take that area and multiply it by how tall it is, and then you would get the three-dimensional volume. All right, scrolling on. Dave says thanks. Thanks, Jeff. I appreciate that. Question 6 of revision sheet of equations. Question 6. Jacob says, "Oops." Awesome. Looks like I probably have Ken or Howard visiting. Let's see. Question 6 of revision sheet. Again, Rolling Stones, I don't know if I have a question. Question 6 of which chapter bit? I presume you're asking... Are you asking about... this one? Geology Cat's going to build something? Okay, let me assume that you're talking about this one here. This is a complex unfamiliar. Complex meaning you have to apply multiple skills, multiple techniques to solve it. Unfamiliar meaning it's relatively uncommon, but still you have the tools to solve it. So here we've got a question, and these are usually going to be the hardest ones to solve. So if you weren't able to solve this the first time, then it's not a big deal, because remember, your simple familiars are worth the most points. Okay, if you can do your basic simple familiars, you're going to be in a good spot. A house that Geology Cat is going to build is 3 times as tall as it is wide. So that means 3 times as tall as it is wide. So it's going to be, so the tallness, actually the height, is going to be 3 times the width of this building, and a third as deep as it is tall. So that means, let me use a different color for this bit. A third as deep as it is tall. So its depth is 1/3 of the height. And then next information I've got, notice how I'm changing colors. That can be helpful sometimes. What is the volume of the house? So that's the main goal. I need to find the volume, so I need to find that. Volume of the house, if it is 12 meters tall. Okay, so that sounds like a height measurement. So let me stick that in there. So I already know its height, so let's just put our thinking space here. So we know the height is 12 meters. Do we know its width? Do we know its depth? We don't know yet, but we can figure it out. So let's use that information of orange and put it into the blue. So 12 meters equals 3 times the width. So let's divide both sides by 3. We should get an answer of 4 meters equals the width of the building. So we can put that in there. So I can literally take that answer and stick it over there. Let me put that away. The depth we can also solve, so we stick that information into pink. So the depth is equal to 1/3 of the height. The height was 12 meters, so 12 meters. So 1/3 times 12 ends up being 12 on 3 meters, and which ends up being 4 meters again. So I can stick that information into my little information guide there. So now I can just do the volume calculation. Volume of the house is going to be height times width times the depth. So let's just put them all together. 12 meters times by 4 meters times by 4 meters. So 4 times 12, 4 times 4 is 16 meters squared, 12 meters. 6 times 2 is 12. 6 times 1 is 6. 6, 7. 1 times 12. Okay, so I should have 2. I should have 9. I should have 1. 192 meters cubed. Okay, so I hope that answers your question there, Rolling Stones. B asks, can you also do question 7? Mathilda wants to know how much money, I quote, it would cost her to have Georgie Cat to build her a raised garden bed for her new veggie patch. The cat replied he charges a $50 call-out fee and a $20 for every hour he works, plus the cost of materials. Okay, so that sounds, straight off the bat, the language there sounds like algebra. He charges 50 and 20 for every hour, plus the materials, okay? So it sounds like it's giving you information about an algebra problem. The first question here, define a pronumeral for the hours the cat will work. So you can choose a letter. So I'm going to use the letter H equals hours. He's working. Define a pronumeral for the cost of materials. So let's just use the letter M maybe for materials. You can choose any letter you like, but I just like to have a letter that matches the thing we're trying to solve. Write an equation for the total cost of Georgie Cat's quote. So I need to have another letter for the quote. So I might just write the word quote is equal to, or I could use the letter Q, yeah? So I could just do Q instead if I want to. The quote is going to be, now let me just take the information from the question and try and put it together. So it says he charges $50 call-out fee. A call-out fee is just the cost of showing up, okay? If you need to bring a truck as a laborer, that it costs you money to go get your truck or rent a truck or do all that sort of thing. So you need to charge a little bit just to be there. Okay, it says and. So and to me means like a plus sign. So $50 and $20. Let me put $20 again. So $20 for every hour he works. When you see that language there, for every hour, that means something times by the hour. So 20 times by the hour, but we already have a letter for that. Let's put it in there. So 20H. Okay, let's keep reading. Plus, that sounds like a plus sign, so we put a plus sign in. The cost of materials, which we defined as the letter M for the cost of materials. So my equation is going to be Q equals 50 plus 20H plus M. D, if the cost of materials of the bed cost $175, so the materials is $175, and it takes the cat 8 hours to build, how much will she have to pay? So let's bring out that rule. So the quote is $50 plus $20 for every hour he works, plus the material cost. Now we just put in the numbers that we just got from the question. So 50 plus 20 times 8 hours plus the material costs of 175. So now we have 50 plus, it's 160 plus 175. So if we add them all together, I should have 5. 7 plus 6 is 13. 13 plus 5 is 18. 1 plus 1 is 2, plus that is $385. Okay? And it says use keyword setting out. So that keyword means like the letter A, which means you have to say the quote will be 385. Okay? E says, Mathilda says it's too expensive for her to afford, so she asks the cat what he can do to lower the cost. He says he can make the box smaller to save on materials. It costs $20 per meter of wood to make the sides of the box, and $7 per meter cubed of soil to fill the box. Write an equation for the total material cost. So material cost, we already defined, we have the letter M for that. So let's see what else we got in this information package in the sentence. It costs $20 per meter of wood to make the sides, and they say it's $7 per cubic meter to fill the soil. So it's going to cost us something, it's going to cost us $20 per meter of wood. So maybe I'll do 20 times L for length of wood, perhaps. Or maybe I'll just say $20 times wood. I could use that instead. Then I can see the word and, so I'll use the plus sign for and. Then we have the information there, $7 per meter of soil. So I might say $7 for the amount of soil. Okay, so I've got a little equation there going. Again, you could use like a letter for wood, and you can use a different letter for soil. So W and S, perhaps. If Mathilda needs her garden bed to be at least 0.5 meters wide and 2 meters long, how much would the total quote be? Okay. So we're already told the dimensions of the box. So that means I can find out how much wood that's going to be. So let's do that. Let me just copy out the equation. So my equation is M equals 20 times the wood plus 7 times the soil. I'm writing the word soil because if I write the letter S, you might think that I'm writing a 5. So I'm just writing the word soil. Now we put that information in there. So 20. The wood that we're using is, we need to have this length plus this length plus this length plus this length as well. So to work that out, it's basically a perimeter problem here. So it'll be 2 times 0.5 meters plus 2 times 2 meters. And that's just to give me the dimensions of the box, where it's 0.5 and this is 2 meters. So there's going to be 2 of these, 2 of these. That's what I'm doing in here. Plus the soil, which is going to be filling that volume, right? So that volume is going to be width times length times height. So let's put that together. So it's 0.5 meters wide. It is 2 meters long, and the diagram here I'm giving to you tells you it is 0.3 meters tall. And you basically calculate all that out, which I don't have time for, but I'm sure you can solve that much. Trying to scroll down, but I don't see any further questions. And I am on 4% battery life left on my computer. I think we're about to lose power, but I see that Lauren has emailed the question. Could you please cover chapter 10, A to G? I am so sorry, Lauren. I do not have my textbook with me this afternoon. So I can't find it unless I struggle really hard to try and log back into Hot Maths, but I don't think I can. Lauren, can I get you to catch up with me tomorrow on Monday, maybe at lunch break or something? And I'll try and run through some of those solutions for you, but I can't do it here because I've left my textbook at work. I think I skipped over somebody else's question. Oh, yes. Before we lose power, I did say that I would try and do this question here for Sophia. All she needs to do is pay for her chemicals and the electricity costs who she uses to run her factory. If the factory costs $2 per hour for electricity, so that sounds like 2 times the hours that she's using it for, write an equation for the total bottle of elixir and define your choice of paranumerals. So I'm going to use this information and this information together. So let me just remove some of these underlines here. So I'm going to use B for bottle. Okay, bottle cost is going to be the chemical cost. So C for chemical cost. And, because and over here, the electricity cost. So the electricity cost is this information here. So that is $2 for every hour. I'm going to use the letter H for hours. So hours of electricity. And, oh no,